Today we are going to cover chapter 3, section 5. It is the last section of chapter 3, and it is a review of algebra 1. We're going to learn how to find slopes and use slopes of lines and how they're related to parallel and perpendicular lines. The first thing we're going to do is define what slope is. So the slope of a non-vertical line is the ratio of a change in y to a change in x, the horizontal change. Slope is always indicated with the lowercase letter m. So when you see the lowercase letter m, that's the letter that they're going to use to represent slope. Slope is defined as rise over run. Now, if you have a graph and it's graphed appropriately and on a nice piece of graph paper or a nice coordinate plane, you can also count the little squares. But if not, you might be given ordered pairs and you will just subtract them. Now, if you have an equation, and we're going to see this coming up in the notes, if it's in this form, y equals mx plus b, again, the letter m represents your slope. So whatever number is in front of x, that would be your slope. So if I gave you an equation, y equals 3x plus 1, and I ask you to find the slope of that line, you would just tell me the slope is 3. Now, a couple of years ago, and this student's already graduated, when we were covering this lesson, he told me a story about his middle school teacher who helped him to remember the formula for slope. Because the most common mistake I see when students calculate slope is they put the change in the x on top of the fraction. If you do that, you will get it wrong. It's always the y change on top of the x change. So what his middle school teacher told him was this story. And what she told him is, you're going to be going on a picnic. And you're going to have your picnic on the side of a mountain. And the mountain has a slope to it. So you want to set up a picnic table to have your picnic on. So what we're going to do is create the legs of our picnic table by using the x's. And then this is the top of the table, which is also your fraction bar. And at that picnic, you're going to be serving some yum yum juice. And you want to serve your yum yum juice in some fancy glasses, and they're going to be shaped like some Y's. And then he added in some more to the story, like adding in some olives or some cherries to the drink. But just know that the legs of the table are looking like your X's, and then the Y's are going to be your yum yum juice glasses. And then you could add in the subtraction signs, and then if you wanted to add the little 2's and the 1, you can. But just remember, the table is formed by those x's, and you always subtract the x's in the denominator. Whatever's going to help you to remember this formula, because you're going to need to use this on the test on Tuesday. Okay. The next has different types of slope. The first one is a graph of a line that has a positive slope. Notice that the graph rises as you move from left to right. When the graph falls down as you move from left to right, it's a negative slope. And when your graph is a horizontal line, then it has a slope of 0. And then the last graph is the vertical line, and that slope is undefined. You are going to need to memorize the slopes for the horizontal and the vertical. Whenever you're given an equation and it has y equals a number, that is going to be giving you a graph that when you graph it will be horizontal. So let's say I add some numbers here just so we can see that this is going to be hitting it at 2. So this line, you could say, is graphed at y equals 2. This is a horizontal line, and the slope is 0. When it's undefined, let's say I add in a line here, then this would be x equals 2. And this would be your vertical line. And maybe a trick to help you that the vertical line is undefined. If you think about how the line looks like it's graphed and it's going up and down. So when your line is graphed and it goes up and down, then if you take the U from up and the N from and the D from down, it's like you're starting to spell the word undefined. So when the graph goes up and down, then your slope is undefined. And then when it's horizontal, it's a flat line and there's no slope to it. Now, when you actually do the calculation, let's say they gave you two order pairs, and you do the y2 minus y1 over x2 minus x1. For the horizontal line, the y's are going to be the same number, and when you subtract them, you're going to get a 0. The bottom will just be some random number. This will simplify to a 0. So after you do the slope formula and you subtract the coordinates, if you get a 0 in the numerator, this is when it simplifies to 0. But when you do the formula, and if you get a 0 in the denominator, that's when it's undefined, because you cannot divide by a 0. So then this would simplify to undefined. I would expect you to simplify when you end up with a number over 0 and tell me it's undefined, or if you have a 0 and then a number, simplify it to a 0. Now, the whole reason of reviewing all of this slope information is how it's going to tie into geometry, and we're going to learn two theorems about parallel and perpendicular lines and their slopes. So the first theorem is the slopes of parallel lines, and in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So parallel lines will always have the same slope. Remember, parallel lines are two lines that are going to go forever and they will never intersect. Remember, the indicator on a diagram that lines are parallel are these arrows. So parallel lines will always have the same slope. For perpendicular lines, when you have two non-vertical lines are perpendicular, if and only if the product of their slopes is -1. And what's going to produce a product of -1 is when you multiply its slope times an opposite sign and a reciprocal of the other. So for example, if I gave you a slope of 2/3, opposite reciprocal to 2/3 would be opposite, so this is positive. So the opposite would be negative, and the reciprocal, you flip the fraction upside down. When I multiply these two fractions, 2/3 times -3/2, I'm going to get a product of -1. So if you notice, I could simplify diagonally here, change all these to 1s, and then now you're left with 1 times -1, and notice the product is -1. Now, you don't need to worry about the fact that the product is -1. Just know that perpendicular lines always have opposite reciprocal slopes. So again, this would be an example of opposite reciprocals. If I gave you a slope of +5, remember you can turn a whole number into a fraction by adding a 1 to it, and then opposite sign and reciprocal to that would be -1/5. So if I gave you an equation with these in it, an equation of a line that would be perpendicular, you could put 2/3 x plus 1, flip it to negative and flip it upside down. And these two lines would be perpendicular because they have opposite reciprocal slopes. Or if I did the one with the whole number, 5x plus 3, and then opposite reciprocal, and I would get -1/5 x. And the b doesn't matter here. I'm just making up random equations. Now, on the test and in the homework, they're going to tell you which order pair to use because it will change that value of that b. Next slide. The slope of a vertical line is sometimes, always, or never 0. It will never be 0 because a vertical line is undefined. Then the slope of a horizontal line is always 0. The slope of a line that rises to the right is always positive. And the slope of a line that falls to the right is always negative. Okay, so on this slide, it wants us to find the slope of the line through the 2 points that are named. So we're going to go ahead and subtract them. Again, I'm using the slope formula. And again, remember, slope is always indicated by a lowercase letter m. So I'm doing y2 minus y1 over x2 minus x1. And remember, these are little subscripts or labels. So this whole first column, this will be all my x1, y1. And then the other one will be my x2, y2s. So this will be x1, y1, and then these will be x2, y2. And I'm just plugging them into the formula. So I'm going to be doing 5 minus 4 over negative 4 minus negative 3. Be very careful. Use your rules for subtracting integers. 5 minus 4 is 1, but this denominator, I could do a keep, change, flip, and it becomes negative 4 plus 3. So then it's 1 over negative 1, which simplifies to negative 1. Always simplify your fraction. If it'll simplify to an integer, do that. If it's something that can't be simplified, just reduce it. Then for part B, again, I'm going to subtract the y's. I'm going to do negative 2 minus negative 3 divided by negative 1 minus 6. Again, you can keep, flip, change it, or stay, change, change. Whatever you do to subtract integers, and then you get 1 over negative 7. Now, you can either leave the negative 1 in the bottom, or you can pull it out front of the entire fraction. Remember, after you do the slope formula, if you end up with only one negative sign, it is a negative slope. But if I would have subtracted and I got a negative in the numerator and a negative in the denominator, then it would have been positive, because negative divided by a negative is a positive. The next one, if you notice, the y coordinates here are the same. So once I subtract these, I'm going to end up with a 0. So I'm going to do negative 4 minus negative 4 over negative 3 minus 8. Again, keep, flip, change. Negative 4 plus 4, and then the denominator becomes negative 3 plus negative 8. I get 0 over negative 11. Whenever the 0 is in the numerator, this simplifies to a 0. Soon as I see that I have a slope of 0, this tells me that this is going to be a horizontal line. And it's going to be a line that's going to go through the y-axis at negative 4. So my equation is going to be y equals negative 4 if they ask you to write an equation for this. Now the next one has x is the same. For the next one, again, I'm going to subtract. So I'm going to be doing 9 minus negative 2 over negative 6 minus negative 6. This gives me 11 over 0. Whenever the 0 is in the denominator, it's going to simplify to undefined. Don't leave your answer as 11 over 0. Show me that it's undefined. Now, on this one, notice my x's were the same. This is indicating that this line is going to be vertical. And if they ask you to write an equation of the line, it's going to be going through the x-axis at negative 6. So the equation of the line would be x equals negative 6. This is when your x's are the same now. Okay, so here they're telling us to complete the table for when r is parallel to s and when r is parallel to t. So what we need to remember here is that parallel lines have the same slope, but perpendicular are going to be opposite reciprocals. So everything that's in the column underneath R is going to be exactly the same as the column under S because R is parallel to S and they have the same slope. So if R is -1/2, then S is also -1/2 because they're parallel. Now when R is perpendicular to T, this is where we change the sign and flip the fraction upside down. So 1/2 becomes 2/1, and I can simplify that to 2. We're going to work backwards. So again, R and T are perpendicular. They gave us T. So I need to flip it and make it negative. So then if I flip 1/6, it becomes -6/1, which is just -6. And then remember, R and S are parallel, so S is also -6. Then in column or row C, they gave us S. Remember, S is parallel to R, so R would be 1/5, and then T is opposite sign and reciprocal, so -5. For D, same thing. They gave us S. S is parallel to R, so it's the same. And then R and T are perpendicular, so opposite reciprocals. So flip it and make it positive, so 1/4. And now E, it's a variable, but that's okay. If it's easier for you to see this as A/1, so that way when you flip it to the reciprocal, it's 1/A and then opposite sign. And then R and S are parallel, so same. And then do the same thing for F. Just flip it and make it negative. So 4/3B, and then opposite sign, it's now negative. And then S is parallel to R, so again, exactly the same answer. The next one is telling us that if R is parallel to S and R is a horizontal line, what is the slope of S? Well, I know parallel lines have the same slope, so as long as I've memorized that a horizontal line has a slope of 0, then that's going to be my answer. So R and S both have a slope of 0 because they're both horizontal. Again, you're memorizing that. Now, if it helps you to think, oh, horizontal has 2 O's in the word, and maybe think of those O's as zeros. Vertical doesn't have an O. Maybe that might help you. So horizontal is always a slope of 0, and when lines are parallel, they have the same slope. Let's try the next one. If K and N are perpendicular and N has a slope of 0, what is the slope of K? Well, again, we already know that N, if it's got a slope of 0, it's going to be a flat horizontal line. And we learned on the slide the perpendicular theorem. We know that the slope of horizontal and vertical lines are always perpendicular. So K is going to be vertical, making its slope undefined. So what you need to remember is that horizontal slope of 0 and a vertical line together, when they intersect, they will always be perpendicular. When a vertical and a horizontal line intersect, they will always be perpendicular.
That doesn't go for undefined.
Okay, so slope-intercept form of a line, also known as y equals mx plus b, where in the equation, the number in front of x, the m, is your slope. The number that's being added or subtracted to the x is going to be your y-intercept. When you go to graph it, it's going to be your beginning point. So when they're giving you equations and they want you to find the slope in the y-intercept, we're going to need to rearrange them first. So I'm going to go ahead and rearrange equation A, which right now is in standard form. But I'm going to rearrange it so it's in y equals mx plus b form, so I can pull out my m and my b. So I'm going to go ahead and subtract the 2x. And I get negative 3y equals negative 2x plus 6. I need to divide all three pieces by negative 3. And I end up with y equals negative 2 divided by negative 3 is positive 2/3. And then positive 6 divided by negative 3 is negative 2. Now that I have it into y equals mx plus b form, my slope is right here. It's the 2/3. And my b is the negative 2. So my slope is 2/3. And my y-intercept, which is my b, is going to be negative 2. Now, equation B is already in slope-intercept. So all I have to do is pull out the slope and pull out the y-intercept. So for equation B, my slope is negative 1/4, and my y-intercept, the b, is positive 2. Now for C, notice it just has y equals a number. So remember, when it's just y equals a number, this is going to be a horizontal line. So whenever it's y equals a number, so horizontal lines, the slope here is going to be 0, and my y-intercept, because it's a horizontal line through negative 3 on the y-axis, my y-intercept is negative 3. Now let me add one more. Let me add a vertical equation. So D, let's say it's x equals negative 1. This one is going to be a vertical line. So this one, the slope is undefined. And the y-intercept is none. Because it's never going to touch the y-axis because it's a vertical line through negative 1. I'm going to graph these three equations on the next slide. Okay. I've graphed the first two. Again, for A, you're starting on negative 2, and you're rising to running 3. And then for B, you started at positive 2. I went down 1 and to the right 4. And now for equation C, which was y equals negative 1/3, this one, remember, is a horizontal line right through negative 3. So notice this one had a slope of 0 and a y-intercept of negative 3. Now when the new equation that I just added, I'll go ahead and graph that one in pink just to show a different color. I added in x equals negative 1. Remember, when it's x equals a number, it's a vertical line, and it's going through the x-axis at negative 1. Notice it never touched the y-axis. This is why the slope is undefined and the y-intercept was none. So be able to recognize these graphs. So the next example, it wants us to write an equation of a parallel line. So in this, they're giving us that they want us to write an equation of the line passing through the point negative 1, positive 1. That's going to be parallel to the line with the equation y equals 2x minus 3. So what we need to take away from this problem is recognizing that parallel lines have the same slope. So the slope that I'm going to be using is the slope from this line and the slope from this line is 2. I'm also going to use the order pair, -1, +1, and that is going to be my x and my y value that I'm going to be plugging in to y equals mx plus b. So what I need to do is find the y-intercept of my new equation. When I did the examples before, I picked random y-intercepts. But for this, you have to do the calculations using the order pair that's given. So I'm going to write down y equals mx plus b. I'm going to replace the m with this 2. I'm going to replace the y with the -1. And then I'm going to replace the x with the +1. And I'm solving for the b. So I'm going to go ahead and plug in my numbers. So the y was -1, my m was 2, my x was 1, and I don't know the b. That's what I'm solving for. All right, let me go back. I did that wrong. Let me change. Let me start over. All right, so let me rewrite the equation. Y equals mx plus b. So the y is 1. It's blue. Oops, let me do and highlight. The y is 1. The x is -1. And the m is going to be pink. It's going to be the 2. So now let me replace. So y is +1. Then equals 2 times -1 plus b. I need to multiply. So 2 times -1 is -2. Add the 2. And my y-intercept is 3. Now it's just a coincidence that it's the opposite sign. It's coincidental. It's not always going to be the opposite sign. So now I take the y equals mx plus b again. I'm going to use this slope and this b. So I'm going to plug those in. So y equals 2x plus 3. And that will be my equation that is parallel to y equals 2x minus 3 that goes through that specific point of -1, +1. Now, you might have also learned point slope. That's another way to do it in your algebra course, but we're just going to stick with slope intercept. The next one is the same thing, however, it's going to be perpendicular. Example 7. So this time they want an equation of a line J passing through the point 2, 3 that is perpendicular to the line K with this equation. So the first thing I need to do is take this equation and get it into y equals mx plus b. So I need to subtract. And the slope of line K here is going to be -2x plus 2. So my slope is -2. But I want a perpendicular slope, so I need to make it opposite sign and reciprocal. So the m that I'm going to be using is +1/2. I'm using the coordinate that they gave me. This is x, this is y. I'm going to plug it in to y equals mx plus b. I'm going to replace the slope. And then I'm going to replace the x, and I'm going to replace the y. And solve for b, and then plug them back into the equation. So my y is 3. My m is 1/2. And my x is 2. I'm solving for b, so I'm going to multiply. 1/2 times 2 is 1. Subtract the 1, 2 equals b. So now I use that new y-intercept with the slope, the perpendicular slope, and plug it into y equals mx plus b. So I get y equals 1/2 x plus 2. And that is your equation that is perpendicular to the original given 2x plus y equals 2. Example 8 wants us to find the distance from a point to a line. Remember, the distance from a point to a line is that perpendicular distance that we're looking for. So the first thing we need to do, step number 1, is going to be to find the slope of the line that's perpendicular to the given line. And my given line is the y equals negative x plus 3. So a slope that is perpendicular, so the perpendicular slope is going to equal positive 1. Because opposite of negative 1 is positive 1, and then the reciprocal of 1 is just 1. So now I need to find the b. And I'm going to do the same thing that I just did. So I'm finding the b, the y-intercept, by plugging in the order pair they gave me for my x and y, and the slope that I just found that's perpendicular. So y equals mx plus b. I'm going to replace y with 0. My slope is 1. My x value is 1. I'm solving for b. 0 equals 1 plus b. Subtract the 1. Negative 1 equals b. This is now my y-intercept of the line that's perpendicular. So I'm going to use the b and the slope. Y equals mx plus b. Replace the m. Replace the b. I don't need to really put a 1 in front of the x. It's assumed, but you can put it there if you need to. Now what I need to do is find the order pair where these intersect. So I have to solve a system of equations. So I'm going to take my original y equals negative x plus 3 along with my newly formed perpendicular equation, and I need to solve the system. I'm going to use the method of substitution. I am going to substitute what this y equals, which is this, in for this y. So essentially I'm just setting them equal to each other. I need to find x, so I can subtract x. Negative 2x plus 3 equals negative 1.
Wait, miss, you're just canceling out.
And then now I subtract 3. Negative 2x equals negative 1, negative 4. Divide by negative 2, and x equals positive 2. I now need to find my y-coordinate. I can plug the 2 into either this equation or this, it doesn't matter. I'm going to go ahead and use this one. It looks like it's less work. So y equals x minus 1, plug in 2. 2 minus 1, y equals 1. So now the order pair is 2, 1. I'm now finding the distance between this order pair and the one in the original problem. Now I need to do the distance formula. So I'm going to be doing x2 minus x1 plus y2 minus y1. And this is squared and under the radical. Negative 1 squared plus negative 1 squared. Negative 1 squared is 1. 1 plus 1 is 2. So the distance in simplest radical form is the square root of 2. If this is a question on big ideas, you will round to the 10th place and 1.4.